When power is first applied, it takes a few moments for the processor to boot up. When the processor is booted, a splash screen will be displayed. This will be displayed until data is actually received from the tracking program. When the tracking program sends data, the display will change and display the current azimuth and elevation of the pointer as it tracks the satellite. Here's some sample data so you can see the display. While the power is off, you can move the pointer and adjust it so it's pointing 0 degrees azimuth and 0 degrees elevation. You can then turn the power on, and the processor will use this as its reference. And it will sit and wait until data is received from the tracking program. Here's some just made up data so you can see that it actually does move. You'll have to take my word for it that it actually does display the tracking information correctly. All the circuitry is located on two small circuit boards located underneath the motors. The board on the left contains the microcontroller and serial EEPROM that actually holds the program. The board on the right contains the driver for the motor. It uses hex FETs driven from some small signal NPN transistors. The transistors, the hex FETs in the output, are good for something like 10 amps or so, but if you're going to run more than a couple amps through them, you'd probably need to add some heat sinking. The LEDs aren't really necessary, but they're an invaluable aid when troubleshooting, and they look kind of neat. It turns out the only really expensive part of the whole thing is the LCD display, and that's actually not really necessary either. The thing works perfectly well without it. So, 73s.